Okay, imagine this. The entire digital backbone of a country just vanishes. Poof, gone in a matter of minutes. Today, we're looking at a completely thrilling, high-stakes moment in tech history where the actual precursor to the internet completely collapsed. Welcome to this explainer, where we're going to dissect the anatomy of a massive digital disaster.
So there's a number that should absolutely terrify any modern systems engineer, and that number is 1. It took exactly one single silent software bug back in 1980 to take down an entire nationwide network. Not a coordinated cyber attack, not some massive power grid failure, but a solitary, invisible glitch that brought a technological marvel completely to its knees.
Okay, let's dive into this and set the stage. We all know ARPANET was the foundational precursor to the modern internet. But remember, this wasn't just some casual academic experiment in a basement somewhere. This was a massive, highly monitored project funded by the U.S. Department of Defense. The stakes here were incredibly high. This was the absolute cutting edge of communications technology, and it was designed to be robust, resilient, and virtually indestructible.
Part 1. The Silent Glitch, Patient Zero in Massachusetts.
Well, even the most robust systems have a breaking point, right? And the start of this nationwide catastrophe was honestly incredibly mundane. Deep inside a facility at Boltzberg Neck and Newman, that's BBN, in Massachusetts, a totally routine router experienced a slight memory glitch. It was essentially a tiny digital hiccup. The hardware was totally fine, the connections were fine, but deep in its memory banks, a microscopic piece of data just became garbled.
But this local hiccup quickly became a spreading contagion. See, that BBN router didn't just sit there quietly with its glitch. As part of its totally normal operation, it began broadcasting routing status messages to tell the network how it was doing. But because of that memory glitch, those messages now contained corrupted data. And almost like a virus, this router unwittingly sent these corrupted, garbled messages outward to absolutely all of its neighboring nodes.
Section 2. The algorithm's betrayal, when self-healing turns deadly.
In any thriller narrative, there's always a plot twist, and here's ours. You'd think a Defense Department network would have a built-in protector, right? And it did. And this brilliantly illustrates the tragic irony of it all. Initially, the intended function of ARPANET's built-in self-healing algorithm was to automatically correct and back up routing tables. If a node saw bad data, it was supposed to fix it. But in reality, because the algorithm prioritized propagating information fast, it aggressively pushed the garbled data forward. Instead of rejecting it, the corrupted log became the new master copy, actively overriding the good data on every single node it touched.
The sheer speed of this failure is honestly breathtaking. Think about the timeline here. Millisecond 1, that tiny memory glitch happens at BBN. Within seconds, the corrupted messages are broadcast to the neighbors. The self-healing algorithm kicks into overdrive, prioritizing speed above all else. Within just minutes, that bad data violently overwrites the good data nationwide. And mere minutes later, complete national paralysis. The entire network, stretching all the way across the United States, completely paralyzed itself.
Section 3. The Manual Reboot, a low-tech solution for a high-tech disaster.
Just like that, the high-speed digital world stopped dead. Total silence across the network. Now, the panic must have been absolute. The very first instinct of any network engineer is to log in remotely and fix the code, but there was a massive problem. The corrupted code had propagated so aggressively that it fully saturated the local memory banks of the entire network. There was literally no memory space left to process a new command. The engineers were completely locked out of their own creation. Remote login was impossible.
So what do you do when the most advanced digital network on the planet locks you out? You resort to the oldest IT joke in the book. Step 1, manually turn off the node. Step 2, physically unplug it from the wall to let the corrupted memory fully drain and wipe. Step 3, hard reboot from scratch. I mean, it is incredibly ironic that fixing a cutting-edge Defense Department system required highly trained engineers to literally walk around a room, grab a cord, and yank it out of the wall.
So the crucial point is grasping the sheer, staggering scale of what this meant. Every single ARPANET node across the US had to be manually turned off, physically unplugged, and hard rebooted one by one. They couldn't just throw a master switch. Techs across the entire country had to physically travel to the hardware, power it down, unplug it, wait, and boot it back up, node by painful node, restoring the system entirely from scratch.
Which brings us to the ultimate takeaway of this explainer. Think about the device you're using to listen to this right now. We live in a world that is entirely dependent on hyper-connected, automated, self-healing cloud infrastructures. But if the foundational internet, a closed, highly monitored defense network, could completely paralyze itself in a matter of minutes from one single silent bug, well, just how vulnerable are the systems running our modern world today? It's definitely a sobering thought, and one worth keeping in mind the next time your internet briefly drops out. Thanks for joining me on this explainer, and keep questioning the systems around you.